So in part D, we need to write down the eigenvalues of our transition matrix. So for that, we first need to find the eigenvalues, and then we can find the eigenvectors. So we need to first find where the characteristic polynomial is equal to 0. So we can do that if we go in our calculator menu, algebra, so find roots of polynomial, degree 2. This is 1. This is minus 1.8. This is 0.8. So we see that our two eigenvalues are 0.8 and 1. So now we need to use these to find the eigenvectors. So what we need to do is subtract these eigenvalues from our matrix. So we need to do 0.88 minus 0.8, that's 0.08. And then this stays the same. And then we again subtract it. This will be minus 0.72. And this other one will be 0.072 and 0. Oh no, from here we obviously don't need to subtract it. We only need to subtract it. We need to subtract the identity matrix times lambda. So we only need to subtract from the main diagonal. So this is also 0.12. And we need to find a vector AB that if we multiply it by, we get 0, 0. So an example of this is 1 minus 1. We can simply look at these two components, flip them. So here it's not very visible. I think in the other one it will be a little bit more visual, but we can take these components, flip them. So what I mean is put the first one in the second place and put the second one in the first place and just change the sign of one of them. Because in that way, these vectors will always be perpendicular to each other. Essentially, that is what we are trying to do here. So we're trying to find a vector that is perpendicular to this and to this. And that's how we can do it very easily. And then for lambda 2, we need to subtract 1 from the main diagonal. This is minus 0.12. This is 0.12, 0.08. And this will be minus 0.08. And again, we need to find a vector AB such that it's going to be 0, 0. So again, we can do the same trick. So what we can do is just flip them. So put the first one in the second place and put the second one in the first place and just switch the sign of one of them. So this works. And if we want, we could make this a little bit nicer. So this is the same as 1 and 1.5.